Today we will be doing the topic alkanes. In this video it will be just a general introduction of alkanes and about the homologous series of alkanes. Now today our topic is alkanes. Now what are alkanes? Alkanes are the hydrocarbons in which all the linkages between the carbon, that is all the linkages between the carbon atom are single covalent bond. It means there should be no double or triple bond. If it happens, then they are not alkanes. So how is the correct way of defining an alkane? So you can say that alkanes are known as saturated hydrocarbon, and they in which all the four valencies of the carbon are fully satisfied by the formula CnH2n plus 2. And how are the valencies satisfied? By single bond. So basically in your definition this general formula should come, and the four valencies of carbon are satisfied by single bond, that is they have been saturated either by C single C or C single bond H. There should be no double or triple bond, then they are alkanes. So you have to learn the general formula. While defining, you have to incorporate the general formula. You have to incorporate the word that the four valencies of carbon are satisfied by the general formula CnH2n plus 2, and the bonds between carbon and carbon and naturally carbon and hydrogen are single bonds. Now the simple alkanes, they share many properties which are common. This we can't comment for the higher alkanes. Higher alkanes means more carbon, that we can't comment. So basically we are referring only to the simple alkanes. Now all the simple alkanes, or basically all they all enter in combustion reactions. Combustion reaction means when you take an alkane, this is the equation for combustion reaction. Clear? So when you take an alkane and you burn it in oxygen, that is combustion, then the products should be carbon dioxide and water vapors. So we can say that many alkanes, again this we can't comment for all alkanes. So many alkanes are flammable, that is the reason they are good fuels. Now for example methane, which is our principal component of natural gas, the equation shown here is your combustion of methane. So on combustion, methane gives us carbon dioxide and water vapors. Now these hydrocarbons, that is the alkanes, they are relatively unreactive. Now why they are unreactive? Now we know the reason, because they are saturated. Their valencies has been satisfied. Since their valencies have been satisfied, so they are unreactive. That is why they are called as paraffins. So alkanes are also known as paraffins. Param means little, affinis means affinity. So they have very little affinity for any new entering into any new kind of a reaction. That is why they are relatively unreactive. They can be made reactive under certain conditions, but if you leave them to themselves, they are relatively unreactive. Now let's go to the next page. Now first let me clean the slide so that visibility is good for you. Now you can see here in this table is discussing about the homologous series of alkanes. So this is the homologous series of alkanes, and general formula of alkanes by now we have learned, it is CnH2n plus 2. So the first member is methane. Remember, this is the molecular formula. This is the structural formula where all the bonds are shown, and this is the condensed formula. Now here the molecular and the condensed is same, so the difference is not clear. Let us come to the ethane. This is molecular formula, this is structural formula, and this is condensed. Condensed formula means you show allotment of hydrogens separately with each carbon. Now here in the molecular formula the hydrogen number was 6, it was shown all together. But here in the condensed formula you show that how the hydrogens are allotted to each carbon. that is called the condensed formula. Similarly, for propane, it is C3H8. Structural formula, you can see all the bonds are single, and here again in the condensed formula you can see that to the first carbon 3 hydrogens are allotted, to the second carbon 2 are allotted, and to the third carbon again 3 are allotted. So this is, you show specific that how many hydrogens are bonding to each carbon. Separately you show, then that is called condensed formula. Now this is normal butane, where all the carbons are in chain. Pentane, all the carbons are in chain. Hexane, all the carbons are in chain. Again you can see this is the condensed. It means with this carbon 3 hydrogens were there, with this carbon 2, with this carbon 2, and with this carbon 3. So this is the condensed, or you can say it as an abbreviated formula also. Now this is molecular formula. So I hope the difference between the molecular formula and the condensed formula is clear to you. So this is all about for this video. We will be continuing with the topic in our coming up videos.